Welcome back, everybody, to I'll Take My Science Neat, a podcast about classy, comedic science. I'm your host, John Rose.
I'm Dr. Rose. I'm here.
You get me to introduce
I'm interrupting.
You. Oh, jeez. She's so great. She just goes at it. Just lets you know, hey, I'm here.
Hey, guys, this is episode 10.
10.
Double digits.
We've done 10 episodes.
I know.
Of course, that's not including our coffee breaks.
Or that's true. It is counting the Patreon episodes, the full Patreon episodes.
Yeah.
But if you want to join our Patreon program, you get an extra coffee break every week. That's like 45 minutes. And then at the end of every month, you get another full episode without ads. Yeah,
the coffee breaks are really cool. You get to hear about us doing some really awesome stuff locally, as well as some awesome science in the background, like me learning how to basically build a foundry from scratch or, melt down some metal.
Yeah, we've been doing a lot of fun projects. So if you want to hear more about that and also some of our extra thoughts on each week's episode, you can check out our Patreon program. It's $5 a month. You can go to I'llTakeMyScienceNeat.com and click the Support Us button at the top.
Of course, you can always just like, share, subscribe, get this out to as many people as you think you can, because we want this to grow larger. We want to have more guests on. We had some awesome guests last week for our Earth Day special. That was pretty dope.
Yeah, if you liked our guests or if you have suggestions for topics or other guests we could have, you can contact us through I'llTakeMyScienceNeat.com and let us know. Also, these things go out to YouTube, Spotify, Pandora, and those things have comments on those websites. If you're on a website where you can comment below, and we will consider. We're always open to ideas, and we want to hear what you guys are interested in hearing about from us.
Yeah, definitely. We are very, very much connected to the interwebs, as the old school. Yeah,
is that what the kids say these days?
That's interwebs, right? And they also say dope and radical.
Oh, yeah.
At least they did when I was growing up.
I was going to say, you're old. All right, guys.
What are we doing today?
This show's called I'll Take My Science Neat, right?
Yes.
And some of that is drinking some really neat liquor. Usually whiskey, not always. But today is episode 10. We hit the double digits.
Uh-huh.
It's a good birthday. And we're gonna celebrate with something a little bit different.
Okay.
We live in West Virginia.
West Virginia.
I know. Martinsburg, West Virginia. And we've recently discovered this place called Black Dog Coffee. And they have a mercantile shop attached to it.
Yeah, and they're not in Martinsburg. They are like off 9, right?
Near Ranson.
Near Ranson?
Yeah.
Is it 9? That's there?
It is.
I'm still getting used to like
it
all
is
the...
9. Yeah, that's 9.
Is it? I'm gonna look it up. I'll let you guys know here in a second.
All right, but the mercantile shop. First of all, we love you guys if you're listening, and we were there last week, and we picked up some sugar cubes that you are supposed to put in your alcohol, and so. Today, we're going to be trying these out. They are bitter orange sugar cubes. They're made with organic cane sugar, orange peel, and bitters. And the cool thing about the mercantile shop and Black Dog Coffee, everything they do is all from the local community. It's locally sourced. They make their own chocolates, which also only have like 2 ingredients. And they're just really into supporting small businesses and supporting locals. So if you're in sort of this part of the country where you can drive to Ranson, West Virginia and check them out.
If you were like anywhere near Martinsburg or anywhere near Charlestown or even like Frederick, it is worth the drive.
100%.
They have wonderful coffee. Then there's like what's the jerkin chicken place right next door.
Yeah.
Like it's a little shop and
it's Jamaican food.
It's so good.
So
we had
delicious.
It today. It's so good. And then you have the mercantile shop right there. And you're gonna find things there that you don't find anywhere else.
You don't find anywhere else.
Like these sugar cubes that you can put in your alcohol, locally made. And it's a lot of local. I mean, like we went and we had a kind of just like a day of like fun. It was actually nice outside for once. We had about the 5 different winters. We're in the process where like, the weather doesn't know what it wants to do. It's like, I don't know if I want it to be spring yet or if I want it to be winter. It's going to snow today, but then tomorrow it's going to be 80. It's like, oh, come on, winter. And it's like, so the weather is crazy. So we actually had a good weekend with some nice bright weather. We went over there, and it was just awesome.
It was a lot of fun.
So we got coffees there. Coffees are really great. I always get my coffee very bitter. I get like half sugar and all that stuff. And then I also get just kind of local things there, like if they have like a muffin or whatever. But they had this like really cool chocolate bar that was all organic, made from scratch chocolate. Tried that. That was so amazing. It was really cool because, like, you know how we had the candy episode and like
just a few weeks ago,
right? And we were like, oh, hey, here's the ingredient list and let's guess. And I turn it around. It's like chocolate and milk and
sea salt,
and
that was it.
And I was like,
the whole list.
Oh my gosh, this is real.
It was delicious.
It was amazing.
It was so good,
so rich. Now a lot of people like it depends on who you are. But if you are like me and you don't like really sugary things, then go to any coffee shop and ask for your, half, syrup.
Or just get a latte with no syrup in it, just milk and coffee.
You
Espresso.
can. I will say though, that's you're kind of a really cool dude if you can do that. And by that I mean like it is super bitter.
That's
I can't do it.
My lab manager just gets lattes every time we go out.
She is a trooper.
She's awesome.
I can imagine that her.
You've gotten distracted.
Sorry,
sir.
go
We're
for
supposed
it.
to be talking about bourbon.
Anyway,
right.
Awesome people.
We love them at the Mercantile Shop. So this week we're going to do something different. You and I are going to have different bourbons because I want to see how these sugar cubes do in two different things. So you are drinking Old Forester Kentucky Straight Bourbon.
Oh, they're pretty good.
It's 100 proof. This is an oldie but a goodie for us. We like this one. So let me hand you your glass.
It's not a small batch, just Kentucky Straight Bourbon, right? 100 proof?
That is correct.
Okay.
100 proof. I am drinking Four Roses. Not their small batch, nothing fancy, just straight up Four Roses. Oh, the cork is really tight. Okay.
Oh, I don't know if that came across.
I don't know if it did either.
It was very like boom.
I couldn't hold it close to the mic because it was difficult to get out.
It was yeah. And this is just regular Four Roses. We felt like we wanted, this is kind of like, because bourbon's really, it's special, right? Like each one you try, it's different tastes and everything like that. Kind of we're thinking, well, let's try to go with normal stuff. We're going to try out
some things. You usually don't
cubes.
mix sugar and things into like a $90 bottle of bourbon.
Yeah.
So these are good, like, $20, $30 bottles. You guys could try this at home.
Yeah.
So I don't think we've done Old Forester on the show yet. Why don't you take a sip and tell us what you think it tastes like?
Okay. All right. Going for the sip test. I would say it's like bourbon. Like you're very not almost. I'm not trying to knock you, Old Forest, but like there's not too much taste there. It's just really harsh.
It's just bourbon,
and
like straight up drinking bourbon.
I totally get the oak. I get that really hard. So
do you get that like grain? Is it a little grain forward?
It's not too grainy. But I get a huge like slap in the mouth of oak. And it's up front.
Okay.
I mean, it's good. Like I mean, if I was poured this, I'd be like, all right. But I wouldn't go searching for it. You know what I mean? Like this.
It's not blowing your mind.
No,
all right, I'm gonna drink this Four Roses. I think Four Roses. A lot of people, it's like a go-to for us for sure.
Right. I know we like the small batch a lot.
Yeah, this is not small batch. It's a little bit sweet, a little bit oaky, maybe a tiny bit peppery at the back. But again, I wouldn't go searching for it. It's an okay bourbon.
Yeah, if you were like,
it.
I need a bourbon to mix with, like if it's,
I would mix with this
because you can make really good drinks like old fashioned. Love old fashioned.
And the bourbon you use to mix matters. Like
yes,
All right, I'm gonna hand you a sugar cube.
By the way, I do want to say Mercantile Shop and Black Dog totally off of 9. Between Martinsburg and Ranson. And if you're near Kearneysville, very close to there.
Yeah. Or if you're in Winchester, Virginia, you can just pop up across the border.
You can always look up Shenandoah Junction. So.
Yeah. All right, I'm handing you one of these orange bitter sugar cubes.
Oh, okay. Oh.
So pop that in your drink, swirl it around.
Oh, I'm smelling it.
Smell really good.
They smell really good. Can I just like... no, okay. Okay.
You might have to drop it in.
It's been dropped.
You might have to swirl it a little bit and give it a minute because it's not like It's not going to dissolve right away.
What are you talking about? I thought it was going to be an instant dissolvification. It's getting there.
So if you guys are interested during the patron episode, because we do a full long patron episode at the end of every month.
Yep.
We also picked up some lavender cubes. We're going to be trying in some different kind of liquors.
Lavender.
So if you're interested to see how those taste, you can always check out this week's. What are we talking about on the patron episode? Green energy this week, I think. This month.
Yeah. It's green energy. What is the name? I'm curious what the name of the company is that makes the cubes.
It is handmade. Vena's Fizz House.
Venice Fizz House. Okay.
Yeah.
So check that out if you're interested in like just something that you can add to your drink. Really cute too. Like we were in the shop and we saw these and we are like, oh, this is like something you can just add to your drink. They had other things too. So I'm excited. I'm gonna let mine dissolve.
I was gonna say it's gonna take a while. Let's come back after maybe the first
what else
portion,
do we need to talk about?
Like halfway through the episode, and we'll let you know if the sugar has dissolved and what it's done to the taste.
Yeah.
Thank you guys so much for tuning in. Today we are talking about volcanoes.
Whoa. What?
Yeah. Kind of an explosive topic.
Yeah. There's been a lot of volcano activity recently, right?
I think there has been. Yeah. I've definitely been hearing about volcanoes in the news. And I think just a lot of people are, it's our childish wonder. Volcanoes are really cool, and there's a lot to learn about them. And so today isn't like breaking news science. It's not a hot topic in today's political atmosphere, but it's cool science.
But it is a hot topic.
It's a hot topic.
Ah.
So we just want to share with you guys some cool facts and some cool science about volcanoes today. But we are going to go to a quick break, and if you hang on, we will come back with more bourbon, more volcanoes, and more science in just a minute.
Hey, everybody. We're back from a really quick break there. Okay, so we right now have some really nice sugar cubes in our drinks. We're letting them dissolve. Got some cool stuff going on today. We're talking about volcanoes. Volcanoes.
Yeah, we're talking about volcanoes.
It's a hot topic.
Yeah, it is. So I'm pretty excited about today's episode. I think volcanoes are super cool. There's a lot of, if you're into history, volcanoes have played a super important part in history. If you're into world religion, if you're into a lot of different things, volcanoes are really ingrained in our culture and in our minds and in our history. And so science on volcanoes, I think, is really captivating for all of us.
Yeah.
So I'm going to jump right into today's first paper. This one actually is from 2018. Well, it just came out last year, 2020, but the title is Air Quality Impacts of the 2018 Mount Kilauea. It's in Hawaii, guys. I don't know how to pronounce it. And that volcano eruption and a regional chemical transport model study with satellite-constrained emissions. So that was a lot of words, but basically a volcano in Hawaii erupted in 2018, and they're making a mathematical model based on the chemical output of the volcano and the atmosphere and a lot of stuff to figure out what kind of effect it had on the local area.
Sounds like a lot of cool, hot science.
Hot science. All right. There's a long list of authors, and we want to thank every single one of them.
Yes.
Are you ready?
That's what we do. Because, other people, mainstream media, they don't cite anything. They don't talk about anything. And they definitely don't thank all the authors who, put in part of their lives in creating cool research. But we do. We do it because they won't.
He's passionate today, guys.
We're passionate.
All right. Thank you so much to these authors. Joshua Tang, Daniel Q. Tong, Kai Yang, Pius Lee, Barry Baker, Alice Crawford, Winston Luke, Ariel Stein, Patrick C. Campbell, Allison Ring, James Flynn, Yuxuan Wang, Jeff McQueen, Lee Pan, Jianping Huang, and Ivanka Strajner. I hope.
Thank you so much for this research. That's a pretty long list.
That's a very long list. Sometimes a lot of people have to work together.
I'm kind of curious. I mean, I don't know if you want to play or not, like a little game.
Okay.
Would you be interested?
It depends what the game is.
Put you on the spot. I want to see how fast you can say all these authors.
Right. Well,
we can play
pre-gamed before the episode a little bit, so I might slur my words.
We can place a bet.
A bet? What's the bet?
Let's see. If it takes you less than how long do I think you can do this for? If it takes you less than 20 seconds. 20 seconds is a long time.
That's a long time.
You think you can do it in 20 seconds?
I think so.
If you can do it less than 20 seconds, I'm trying to think of something that would be cool. What would you? Is there something you want? You don't want?
I don't think I want anything cool.
You don't?
I think
what about
I want
hot?
like
a volcano? You want a hot volcano?
I want a volcano.
I need one of those. Put it in my backyard.
I don't know. You put me on the spot.
I guess I'll pour the bourbon on the next thing.
That's not really that great of a bonus, but I'll take it.
I was putting it. You could have said, "Hey, you do unload the dishwasher. You cut my vegetables for dinner. You could have said any of that stuff. Instead, you're like, oh,
I want another jar of sugar cubes from the mercantile shop in a different flavor.
Okay, done.
If
you can get it under 20 seconds. How many authors is this?
1, 2, 3, 4, 5, 6.
A lot of authors. You sure you got this?
Is 16 authors? 17 authors? I lost count.
17 authors.
All right. Are you starting your timer?
Give me a second. I'm getting the timer.
How close do my pronunciations have to be?
They have to be pretty close.
All right.
I mean, come on. Don't. I wouldn't want you to butcher my name. Be like Ron Rose. Instead, you're like, Robert. You actually have to pronounce it.
All right.
But do your best, and I think the audience is going to listen in, and they'll let you know how you do. How about that? Okay. Are you ready?
Give me a countdown.
Here we go. 3, 2, 1, go.
Joshua Tang, Daniel Kugatong, Kai Yang, Plios Lee, Barry Baker, Alice Crawford, Winston Luke, Ariel Stein, Patrick Campbell, Allison Ring, James Flynn, Yuxun Wang, Jeff McQueen, Lee Pan, Jingpeng Huang, and Ivanka Stranger.
Woo! Guys, I got you. I let it go for like 1 minute or 1 second. I let it go for 1 second. That was 12 seconds.
I feel like
60.
I did good.
You did really good. I was like, oh wow, she's doing awesome. And then you like stumbled off of one. Guys,
I stumbled because I had to take a breath.
And I understood each one of those.
Breathing is important.
Anyway, I still stand by my theory of every single person who's done some really cool research has an amazing name. All you authors are super awesome. Where was this published?
This was published in the Journal of Atmospheric Environment in 2020. It also had quite a bit of funding you might be interested in.
Oh, yeah.
It was funded by NOAA, National Air Quality Forecast Capability. It was funded by NASA, Health and Air Quality Program.
I have no idea who those guys are.
NASA? No, I don't either.
Yeah, definitely not like a big name anything.
And it was also funded by NOAA and the branch of Joint Polar Orbiting Satellite System Program. So basically the National Oceanic and Atmospheric Administration, that's NOAA, and NASA is the National Aerospace. Is that what? It's just aerospace, or is there another word?
You mean to say the National Aeronautics and Space Administration?
Yeah. Okay.
NASA.
Good. So NOAA and NASA funded this work, basically.
NOAA has some contracts with NASA. So
yeah, they collaborate a lot.
They're buddies. They're like tag taking it up. Like, let's go,
buddy boys.
It's like Superman and Batman, except way cooler.
way cooler. Way cooler. All right. So, like a lot of good papers, this paper starts with an introduction with just some basic information and facts about volcanoes. So, one of the things we know about volcanoes is that when they erupt, they throw a ton of sulfur dioxide and ash into the air. And that obviously has a huge impact on the local air quality. But we also know that local air quality affects the local ecosystems, so the plants and animals that live nearby.
Okay.
And so this paper was trying to quantify the impact of a volcano eruption. Obviously, they're not looking at the lava flows and all that stuff. They're just looking at the sulfur dioxide and ash that's thrown into the air. And they were trying to sort of make a mathematical model based on the strength of the eruption to see how far it would spread through the local area.
Oh, wow. That's super cool. So basically, like, okay, volcano, I'm gonna erupt. It's just like that, right? Volcano erupts.
Those were good sound effects.
Thank you. And it pushed us all, ash and just dust, clouds out everywhere, and it blocks the sun. It's, oh my gosh, it's a volcano just erupted. I don't know why I'm on this island, but, it's just like that happens. Blocks out the sun, and just affects all the air quality. And they are working to basically model how much force is pushing up and how far that cloud, that air quality is.
Exactly.
That's cool. Very cool.
Yeah, and so they were interested in, they were using satellite. So, like satellites can see clouds.
Yeah.
So satellites can also see the extent of the cloud that a volcano throws up.
Right.
And so they were using mathematical models to assess this particular explosion in Hawaii in 2018. And they wanted to know how it was affecting air quality over the islands of Hawaii. And so interesting, I don't know if I'm pronouncing this right, guys. The Kilauea volcano is the youngest volcano in Hawaii's Big Island. So all of those islands are volcanic.
Mm-hmm.
And so basically, as the volcanoes erupt and they let lava flow, the lava turns into rock and it makes the islands bigger. And so Kilauea is the youngest of those islands. It is also one of the most active volcanoes in the world.
Probably doesn't have its driver's license yet.
It's probably not old enough.
It's not old enough. Can't drink. Yeah.
So in 2018, that volcano erupted from April until August. It was a long, slow eruption.
From April to August.
Yeah.
It just was spewing out lava.
Continually erupting, yeah.
It's just mad all the time.
And so they sort of walk through a timeline of the volcano. So it started with lava and sulfur dioxide, which came from fissures in the Eastern Rift Zone. So anytime...
It all started with Chipotle.
Right.
And then...
It's a bad news after that. So they call this Eastern Rift Zone the ERZ. Because there's a part on the eastern part of the island where there's a big rift and the lava comes out of that. And so throughout the next month into May, the lava, they call it a lava fountain, opened up from new fissures that were like downstream from the ERZ. So they were tracking the different parts of the island and as they were erupting. And then also, so you've got this fissure on the east side, but then you have, like a normal volcano, you expect it to erupt out of the peak of the mountain.
Yes.
So that's called the summit.
Ooh.
So it also did that, it erupted out of the summit.
It does those things, yeah.
And part of the summit collapsed, which threw a big ton of ash and sulfur dioxide into the air.
Explosion. Ooh.
Yeah, and so when lava, ash, and gases are all thrown into the air, they form something called volcanic fog, which they call VOG, V-O-G. Which I
have foggy brain all the time.
Yeah.
So, yeah.
I think that's kind of a weird name, but that's what they call it.
I get to about Thursday, and that's when fog starts happening in my brain.
Right.
Yeah.
Oh, yeah. Thursdays are rough.
Thursdays are rough.
So they were actually able to use satellite data. I was saying that you can see basically the VOG, the cloud, on satellites.
Mm-hmm.
And they used it to make a chemical transport model to estimate how far the sulfur dioxide was getting, past the island. And so they basically treated the volcanic emission like a point source in the same way that they model wildfire spread and the pollution from wildfire. So it starts as a single point, and then based on the wind and temperature and altitude, they make a mathematical model for how far it distributes.
I have seen those pictures of the wildfires in California, and seeing that from a satellite.
Yeah, so it's pretty similar.
It's always pretty, yeah. And it's always
volcanoes are much a bigger impact in a shorter time than a wildfire. But yeah, that's a similar mathematical model.
That's very cool that they're trying to calculate that.
Yeah. And so they actually were able to use the size of the volcanic plume on the satellites to double check their math to make sure that, that was their checking variable to make sure that their numbers made sense. And they found that their mathematical model was actually a really good predictor of how the clouds spread.
Wow. So they're they had the model beforehand. And they were
Yep.
like, this is what we think based off of what we know.
Right. And then the volcano erupted and
they're
they
like,
found.
Perfect time to check.
Yeah. And they found that their model was actually a really good predictor.
That's cool. It's almost like we should fund science.
Yeah. And so they were talking about the major health consequence of volcano eruptions is for humans is air pollution at nose level, right?
I
if
imagine.
you're walking around, if you're breathing it in.
Yeah.
And they said at nose level, their model wasn't very accurate yet, but at upper atmospheric levels, it was super accurate. So they took what they learned and they're going to work on their model for the next volcanic eruption. And they're going to see if they can model sort of the human effect a little bit better.
That's very cool. So they're trying to figure out, like, if a volcano erupts, like Pompeii or something. I know that's the one everyone thinks of.
Oof.
Yeah, that's a little bit worse than just nose level, right?
Yeah.
But if it does erupt, what would it be like significantly for people on the ground?
Right, for people on the ground. And also, like, we know that volcanic ash in the atmosphere creates what's called like a volcanic winter, like Mount St. Helens or Pompeii or any of the really big eruptions.
Yeah.
And actually it decreases the Earth's temperature, it blocks out the sun, it decreases photosynthesis. So right now their model is really good for projecting that plume, that smoke plume, and that's already like when you block out the sun, you're decreasing temperature. It's bad for the plants, bad for the animals. But what they haven't figured out is that breathing in human impact. So they have to, that's the thing about science that's really cool is you go do science, you check your science, and if it wasn't quite perfect, like their model wasn't quite perfect, they go and tweak it a little bit more and they get better at it.
Yeah, I mean, and that's really what science is about because, and I mean, we always have the argument of like scientific discourse is so important.
Yeah.
I mean, I literally, and not to get a little bit of personal life of ours, but you are a scientist. You work with amazing scientists, and I'm working, and I just hear you guys talking and having that scientific discourse in your meeting, and I'm thinking to myself, I'm like, man, like that's so great that you work in a lab where you guys can actually just talk things out, and say, oh, this one doesn't work, but this probably would work.
Yeah,
like it seems like we need to have that, and right now it seems like people aren't allowing for that, and yeah, I definitely agree. Discourse is incredibly important, and the ultimate goal of science is, invention and then innovation.
Yeah.
To progress humanity, so then we become better, and we make the environment better.
Yeah.
Make sure that neighborhood looks good.
100%.
Yeah.
So this was a really cool paper. It was very math heavy, but math is part of science. And they had some interesting conclusions. So they found that the volcanic pollutants emitted from this eruption significantly affected the atmospheric environment of Hawaii and surrounding areas.
Okay.
So they were able to model that. They also found that aside from the immediate increase in sulfur dioxide, like what's immediately thrown in the air, the volcanic eruption also affected the entire photochemical process of the atmosphere.
Whoa, okay. That was a lot of words.
Yeah.
So sulfuric acid is...
Sulfur dioxide. So
What's
that's basically the sulfur-based gas that rotten
eggs, right?
Rotten eggs, right? It smells like rotten eggs, and that's what volcanoes put out.
Okay.
Yeah.
Okay.
And so when it goes in the air, so you have this increased sulfur dioxide, and there's a couple things that are happening with volcanic eruptions. So photochemical process. What do you think photochemical means?
Photo, I think of my phone and taking photographs.
Okay.
But
what if I say like photosynthesis or...
Oh, I know what that means.
Okay.
That's plants. They're like, yeah, I want sunlight.
Sunlight,
yeah,
right? So photo is...
the plants get the sun and they turn into energy, right?
So photo is light.
Photo, light, okay.
Okay, and
is
chemical.
That Latin?
I mean, it's the same root word as photon. I don't know if it's Latin or Greek or what, but like photosynthesis, photochemical, photon, like that's all light.
Okay. Photo light, gotcha.
And then chemical. So these are chemical reactions that happen in the atmosphere due to the energy of light. Whenever you have a chemical reaction, you usually need some kind of energy input. So like if you heat something up, you can cause a chemical reaction, or sometimes if you cool things down, or if you if you throw something really hard, like that impact can cause chemical reactions, those sorts of things. And so in the atmosphere, a lot of chemical reactions happen due to light. And with all the ash and stuff in the air, you actually can mess up that photochemical process.
Okay.
And
That's
one
bad.
of the things, so we know that sulfur dioxide, so in addition to the ash, we know that sulfur dioxide reacts with just the OH, oxygen and hydrogen bound together, that's in the air. And it reduces the concentration of OH in the air. So the thing is that when you reduce the concentration of this OH molecule that's in the air, that molecule is needed for a lot of other atmospheric reactions. So when the sulfur dioxide takes that molecule away, a lot of other chemical reactions that are normal and happen in our atmosphere can't happen.
They're like, oh, not cool, bro.
Right?
Need to have these chemical reactions. What kind of reactions happen normally, like using that and just like in the atmosphere? Because I think of rain.
So
of, like chemical reaction, but
yeah, so rain is part of the water cycle. So there are chemical reactions that happen with that. I am not an atmospheric scientist, so maybe we should have an episode on that. But I do know that you have chemicals like a lot of nitrogen heavy compounds. You have, obviously H2O. You've got water. You've got ozone, which is O3. And this OH molecule is going to bind we call it a chemical group. But it's like a hydroxyl group that goes on to a lot of different compounds, and it would be really vital for different chemical reactions. So I'm not going to claim to be an expert on that topic. I'm a biologist.
Okay.
But if people are interested more in that, I can do some research and we could do an episode on it.
Yeah, I mean, I don't know, so I don't expect you to know everything, But I was interested to know what kind of chemical reactions happen in the atmosphere, and maybe our listeners can let us know. Because
I do know. So cool. I mean, and oxygen and nitrogen are like the main components of our. So like O3 is ozone, 3 oxygen molecules. O2 is the oxygen we breathe.
It is.
Yep. H2O, right? That's water. And then you have like a whole bunch of I think you have like NH4 in the atmosphere, which is like nitrogen hydroxide.
And they're all important
hydroxyl
for basically living on the planet.
They're all important for the composition of our atmosphere. It's why
for plants.
Our sky is blue. It's why we can breathe. It's why we don't get fried by the sun. Like our atmosphere is really important. And so sulfur dioxide in the air, and it binding with these OH molecules is actually reducing these other chemical reactions that need to happen.
So if this was obviously volcanoes are natural. It does not really. I don't think there's going to be an initiative to stop a volcano anytime soon. Okay, that's what I was getting to. Is should we be worried about volcanoes?
No, I mean, volcanoes are natural. They're a part of our natural Earth cycle. But they are detrimental to us. So their point was to make mathematical models to understand what's happening. But we also we don't want them to erupt. You don't want to purposely.
I just don't want to be around when they do. I'll be like, okay, so I'm going to be off that day.
Yeah. So this was a pretty fun study. I feel like I learned a lot. This is not an area I'm an expert in, obviously. But I thought it was pretty cool that volcanoes can have this impact and that we're able to use atmospheric models to figure out how far their impact is going to spread beyond the local area.
And the first thing I can think of is that if you have that model, then if you know that there's suddenly Mount St. Helena is the one we think of all the time.
Yeah.
If we're there's some activity going on,
right.
ring. Hello, Noah. Yeah. Can you project if this bad stuff goes down, can you tell me how bad it could possibly be?
Right, and
based off your models?
And then you could say hey, everyone in a 2-state area, clear out.
Sounds like that's pretty important.
Yeah. So this was a really fun paper. Before we go on to our first little, it's not a game, just our first little fun bit. My sugar cube is dissolved. Is yours?
Is it? Let me look. Oh, I have a little bit left, but I think it's good. Yeah.
All right. So we're going to try this with the sugar dissolved and let you know if it improved our bourbon.
Okay. All right. Yeah, I have a little bit of an orange taste. It's not
It's not strong. There was no instructions on how to how much sugar to bourbon you should dissolve. So I think we
did
both
2
got
fingers of bourbon.
like a finger and a half.
A finger and a half.
Something in there.
Yeah. And it was 1 cube, but I mean, you could put in more if you want to be sweeter.
I definitely it wouldn't be overwhelming to put in 2 or 3 cubes.
Yeah, like I was honestly though, I don't like super sugary things.
Yeah,
that was pretty good.
Yeah, you definitely get hints of orange, but it's still very much like the base flavor of the bourbon.
Mm-hmm.
With it just takes the edge off of the harshness and adds a little bit of orange.
And we're gonna do lavender.
We are gonna do lavender cubes. I'm really excited for that. The lavender might be better, and we might try it in a gin or a vodka or something.
Ooh,
that could be fun.
Okay.
But yeah, so check out these sugar cubes. It's just like a fun way. We're pretty much still drinking straight bourbon, but it just adds a little bit of flavor. Like if you don't want a full cocktail, just add a little sugar, a little orange. Super good. So these were made by Vena's Fizz House, and if you're in the Panhandle of West Virginia
Shenandoah Junction
check out the Mercantile Shop and Black Dog Coffee, because we got these from them, and we also got a ton of good distillery recommendations recently. And keep an eye on upcoming episodes, because we've got a lot of stuff coming up. So real quick, before we go on our break,
okay,
I want to play a little skit called Who Funds It? Okay. On this show, we always announce who funds each paper that we talk about.
Yeah, we always say that's really important, because
right, you want to know
could the science be biased?
Could the science be biased or anything like that?
Who's funding it, because that could be a little prejudice.
Right. And so this is not a paper. This is actually a Forbes article, but there is a group doing this research that Forbes covered. So this is a venture. This is done at Harvard. There's a group at Harvard that's doing this.
Okay.
And they want to spray dust into the atmosphere to block out the sun. Now, the intention is to mimic a volcano eruption and to cause global cooling, because we were just talking about volcanic winter. When a volcano goes off, all that dust goes in the air, decreases the temperature, blocks out the sun, all of that stuff. So, who do you think funds this research?
Do
you think it's NOAA? Do you think it's NASA?
No.
Who do you think it is?
Is it somebody? Is it? I think Dr. Evil. I'm sorry. I mean, not to kind of poke the boar, but seriously, they're trying to block the sun?
Yep, they're trying to block out the sun. This research has already been condemned by a bunch of countries, including Sweden.
Oh, I wonder why.
Yeah, people are not huge fans of this.
Yeah, I wonder why.
So this research, in large part, is funded by Bill Gates.
Huh.
So this has been your installment of Who Funds It.
So, does he say why he's trying to fund it?
Because global warming, and so this is going to fix it. It's going to be global cooling,
right?
And so we're gonna have
So let's kill all the plants.
Yeah, I mean, so I don't.
Wait.
I'm not an expert in the atmosphere, but this group in Harvard, funded by Bill Gates, wants to do. God, what I've just completely blanked.
Because you have a kitten in your lap.
I know,
that's really
why.
She's just like,
she's
I don't
tiny.
want my son to be blocked, Mom.
I know, it's scary. What is it when you go to other planets and you terraform? Is that the word I'm looking for? Terraform?
Yeah, you're very close.
Yeah. So they want to do that on Earth. They're saying that's going to be the first successful experiment of taking it from the lab to the world.
Not going to sound biblical, but this sounds really bad.
Yeah.
Terraforming, you're doing it to a planet that's desolate. There's nothing there.
Right.
And you're trying to make it a planet with, I mean, we see the science fiction and stuff like that.
Oh, yeah.
We watch Star Trek and all that type of stuff. But our Earth is just fine. I know it's got some problems, but, it's not like, I use the analogy we might be on we might be driving an old car, right?
Uh-huh.
Might be a car from the 1920s, but it's still a nice car, right? It's not rusted out or anything like that. It needs to be It needs some more new stuff. Maybe it needs a new engine. The wheels need to get updated and stuff like that. But it still runs. It's still good. I wouldn't want to blow the car up.
Yeah, that would be bad.
And then start from scratch. What?
Nobody wants that.
Nobody wants that. But so he really is funding research that's blocking sun. Like we're gonna cite that in the description, right?
Yeah. So I will cite this Forbes article. I read a bunch of articles. I can also go find the peer-reviewed papers.
Okay.
I believe they exist. This research has been going on for years with this Harvard group. Yeah. And so they said it's a widespread research into the efficacy of solar geoengineering, and it has been stalled for years due to controversy. Opponents to this research believe it poses an unpredictable risk, including unknown extreme shifts in weather.
I want to point something out, right? You have this I know when you're doing like canaries and stuff. There's like this whole thing about like the ethic.
It takes a lot of effort to get the ICOOC, the animal ethics approval to do any kind of research.
Right. So like just asking, can you use all of humanity as a test subject?
Well,
because it sounds like Bill Gates wants to do that.
Well, you know what's interesting? There's a woman in our lab, and she's planning an experiment right now, and I won't tell you her whole experiment so she doesn't get scooped by some other researcher who wants to do it.
Don't give the secret
But
away.
she's going to go out in the wild and play sounds out of a... She's not going to touch an animal. She's going to play sounds, basically, and see, based on her experiment, see what happens. And she may need approval from an animal ethics committee to play sounds on a microphone or on a speaker in a field.
Because we care about our animals on our planet.
Right, because she could be disturbing local wildlife, and as part of research, we have to be very careful.
Kind of sounds like this would be disturbing.
Right, so
wildlife.
this seems like the far other end. Like, we're going to radically change, like, we're going to do something that causes volcanic winter. Like, that is an absolute tragedy whenever it happens, and we're going to do it on purpose.
And I mean, everyone knows the term nuclear winter because and that's why there was a whole big thing with like the Cold War. We were really scared that sudden nukes were going to fly.
Right.
And it was not so much of, they explode, it's really bad, but the radiation and the fallout from that. There's literally a video game called Fallout. It's Fallout series.
It's really good.
And the like entire world is like just covered in this fog. It's desolate. There's very little growing. And that's because there was a huge nuclear winter once, the bombs dropped. You don't. This does not sound like a good idea. I don't want to just immediately say, I just want to know the reasoning. I guess global warming, right? Okay, our Earth it's warming up. Okay, I feel like we should again. Thinking about the problem too much there. I don't think you want to be like, well, let's just get rid of the planet by suffocating it. I don't think that's what you want to do. We literally are talking about not trying to put too much CO2 up. I feel like you don't want to go and turn around and put something up even more.
Yeah, and think about all of the animals that rely on, like, the sun. Like, I study birdsong, right? And, like, did you know that the sun and the amount of sunlight a bird gets every day changes their whole brain? Like, they have brain areas that grow in response to the sun, and that's how they know when it's time to breed and migrate and all this stuff. And if you block out the sun, you're messing all that up, and you're messing up photosynthesis for the plants,
even,
and you're messing up.
We get vitamin D.
Yeah. So like, and coral reefs, we were saying last week, they have to be at exactly the right depth because they need exactly the right amount of sun. If you put even a little bit of volcanic ash in the atmosphere, you're going to just totally decimate those ecosystems. So, like, it's reasonable that there's controversy around this. It's just kind of crazy. But this is part of science, that, like, scientists should push back against each other and make sure that everything is happening properly.
Discourse.
Yeah.
Talk it out. That's not a good solution. The solution to the problem is simple. All it is, hey, we need to go to greener energies, but just not screw over everybody on the planet as well.
Right.
Okay? We need to move away from CO2 emissions because we think that might be attributing to global warming. Okay, cool. Make an incentive for people to get electric cars. Make car companies make electric cars.
Yeah, but don't block out our sun.
Don't block out the sun. Don't do the opposite thing.
Right.
okay, no offense, Bill Gates, stick to computers. And by the way, work on it a little bit better because my Windows is not that great. That's why I like Linux.
I know.
All
right.
Getting salty over here.
Rant over.
All
right, guys. We have a lot more cool science and games and bourbon and ranting to do, but we are going to do a quick break. We're going to go record our coffee break, our patron episode, and we will be back in just a minute for you guys to talk about more cool / super hot volcano science.
Hot science.
We'll be right back.
See you in a second. Hey, welcome back, everybody. Okay, so we're talking about volcanoes. We're talking about how probably not a good idea to block out the sun.
Yeah.
Bill Gates, stop.
But we're also talking about how some really incredible scientists have been using math to help us learn about volcanoes and predict the spread. And the next thing I want to talk about is predicting when they're going to erupt.
Ooh, that's cool.
Yeah. So this really cool science is from another eruption. You know, we learn eruptions are natural and they're hard for the surrounding wildlife, but they help us learn.
Yeah.
And so this is application of an updated atmospheric model to explore infrasound propagation and detection in Alaska. Now, if you're like me, you read that title and you were like, what's infrasound?
Application of an updated atmospheric model to explore volcano infrasound propagation and detection Alaska.
Okay.
Say that 10 times fast.
Yeah, so
wow.
I was like, I think I know what infrasound is, but I better check to make sure.
What's infrasound?
Well, so have you ever heard of infrared?
Yeah.
So if you go back and listen to our color episode, which was episode 2.
Call back.
Infrared. So red is long wavelengths. So that's slow moving light. Okay. Infrared is even slower than that.
Oh, wow.
So if you think of infrasound, it's basically, think about like the lowest sound you can think of. Is it an elephant rumble? Is it like, you know, like the lowest, deepest sound? Infrasound is slower wave compressions in the air. That's what sound is. So it's so slow we can't even hear it.
Whoa, okay.
You know how like the lower a sound gets, the harder it is to hear?
Yeah.
At some point you can't hear it anymore. And that's infrasound.
Wow, okay.
All right, and so what they were doing... Oh, let me thank the authors.
Yeah,
I'm getting ahead of myself. I got so excited about your science, I forgot to thank you.
Ooh.
All right, the authors are Alexandra M. Lezzi, Hans F. Schweiger, David Fee, and Matthew M. Haney.
Cool.
Thank you so much for
names.
this research.
And thanks for the research.
This was published in the Journal of Volcanology and Geothermal Research in 2019.
Ooh, recent. All right.
And it was funded by the National Science Foundation and the Alaska Volcano Observatory.
I really want to go to Alaska sometime.
I do too. I want to go birding. I want to go whale watching.
Yeah.
I want to go...
Let's move to Alaska.
Oh, no. Vetoed. All right, guys.
Darn.
So the last one was using mathematical models to predict how far the air pollution would go.
Mm-hmm.
This one is using mathematical models to predict... You know how usually you detect a volcano by ground vibrations?
Yeah.
They have that little like needle and it goes
You're
up
like,
and down and then
whoa.
It goes off the charts and you're like, volcano or earthquake or something like that.
Get down.
So instead of using vibrations in the ground, they wanted to try to detect volcanoes by vibrations in the air.
Wait, what?
Yeah, so sound propagates faster and farther than ground vibrations. And so they thought it would be a better early detection if they could hear the rumbling of the volcano before it erupted.
And it's so low, we can't hear it.
We can't hear it. But it travels through the atmosphere. And they were using atmospheric models. So based on the wind, you know, like if the wind's blowing in the wrong direction, it's really hard to hear something. And so like based on the wind at different levels, because the higher up you go, the wind might be different. And the temperature affects how fast sound travels and all that stuff. So they had to make a really complicated mathematical model. And so this study took place in Alaska. Did you know there are 50 active volcanoes in Alaska?
Did you say 50?
50.
What?
50.
Why are people living there? It's cold and there's volcanoes?
Yeah.
Better than California. Just kidding. Just kidding.
We love you, California.
Yeah,
He's
I'm
kidding.
just saying fire over there.
Earthquakes.
There's that.
You guys got problems.
You know, that line that, you know,
the fault line.
That's it. It's going to blow up. I don't know.
So,
there's always the destruction movies.
I know.
In
They always say
California.
it's going to fall off.
Yeah. And Yellowstone
right.
is also, be away from that.
Oh, no, Yellowstone's beautiful. Anyway, all these volcanoes pose a threat to not only the local communities, but air traffic, because there's a lot of air traffic over, I almost said Australia, Alaska.
Cronky.
So every day, roughly 70,000 people fly through airspace in Alaska that's affected by volcanoes.
70,000 people.
Yeah, every day.
That's a lot of people.
It's a lot
in
of people.
one day.
Yep.
Wow. Okay. So they're flying over it. They're like volcanoes and stuff.
Yep.
It's scary.
And so they wanted to find a way to predict eruptions earlier to keep all these people safe.
Oh, makes sense.
And
I'd hate to be on a flight and then suddenly
volcano. Kabam.
Gosh, dang it, man. I need to be in Utah and
I know.
No, be a
and
delayed.
So, like I said, they were using mathematical models. They were using wind, atmospheric temperature, all that stuff. And then, like I said earlier, we can learn something from eruptions and we can double check our math, basically. Yeah. So they made these models and they focused on 2 volcanoes, but the main one they focused on was the Cleveland volcano. It's had over 50 eruptions since 2012.
This is not Cleveland, Ohio.
Nope, Cleveland volcano in Alaska.
All right.
Yeah, and so they basically used a big eruption in 2014 and a big eruption in 2015 to sort of double check their math. And so they were trying to figure out how the ultrasound moved through the atmosphere and how it was different in different atmospheric conditions. So basically your machine needs to know, like, is it windy today? Is it raining? Is it whatever? And then it changes the levels of ultrasound it's looking for.
Just don't ask the local weatherman because he's always wrong.
He's never going to know. And so basically in 2014, on November 6th, there was a big explosion at the Cleveland volcano.
Oh, my.
And it was like a big eruption.
Oh.
But their...
oh, my.
But their alarm didn't go off.
Uh-oh.
So their mathematical model wasn't sufficient. And what was happening was there was a lot of background noise. So when you're listening to sound or ultrasound, there can be background noise. And so they had to sort of clean up their model to deal with the background noise.
But that's awesome. They learned from that.
They learned. And
That's
then
cool.
the next year, in 2015, on July 21st, another explosion, but smaller.
Mm-hmm.
And it did set off their alarm. But what was weird was the wind was actually blowing the wrong direction. So it was a smaller eruption, and the wind was blowing the wrong direction. So they weren't really expecting to hear the eruption, but it did actually set off their alarm. And so they were sort of having to think about what that meant and how, how that affected their model. And so basically what they learned was that when they applied their mathematical model to this data, they created a new mathematical model to help explain some of the variation. And so what the big punchline was that winds are different at the different levels of atmosphere. Okay. So even in the stratosphere, if the wind was going the wrong direction, in higher parts of the atmosphere, the wind was going the right direction. And so that helped move the sound closer to the station that was trying to detect it.
Weird. Okay.
And so I just really like this paper, even though they're still learning. I was like, I had no idea you could detect vibrations through the air that far away, because this was like really, really far away from the volcano. But also I liked it because in the end, their conclusion was, well, it's really important to consider the limitations of our models and that we constantly need to be going back to them. And they said, our model is restricted by the spatial resolution and the time resolution of the atmospheric models. And so we all sort of need to improve together to make this early detection system work.
That's so cool. I mean, I feel like the theme of this episode it goes back to like, when we were talking about, science is about discourse, invention, and innovation.
Uh-huh.
And I really feel like they captured that. They didn't go like, oh, our model didn't work. Well, gosh, it must be Bob. Bob over here did a bad job at setting the model off. The model should be perfect. Gosh, Bob. And then, they didn't do that. They went, okay, what was the reason why it didn't work? And then they went back and then they adjusted for that. And then they found success.
Yeah.
And now they went back, tweak it a little bit more, and they're just going to get better and better.
Yeah.
That's super cool. That's
So,
awesome.
I love volcanoes. I think it's awesome that after all these thousands of years of people thinking about volcanoes, seeing volcanoes, studying volcanoes, that we're still learning more about how to predict eruptions, how the clouds affect the atmosphere, and just like how they work and how we can live around them. But before we end this volcano episode, because we haven't really had a game yet, and I feel like you're not going to get off easy ever. And it is time for a quiz.
No!
So everybody hold on to your hot potatoes.
Not my hot potatoes.
This game is called Hot or Not.
Hot or not? Ooh,
yeah.
Okay.
All right. It's multiple choice because I'm feeling friendly today.
I'm glad you feel friendly.
All right. Which
of
of these melts at the highest temperature? Is it A, porcelain, B, limestone, C, quartz, or D, mild steel?
Okay, melts at the highest temperature?
Highest temperature. So porcelain is like a porcelain doll. Limestone is a stone that like a large part of the United States is made out of.
Right.
Quartz is like it's a crystal.
Yeah.
And then steel, mild steel is, you know what that is.
Yes.
Okay.
If I'm going to guess, I'm going to say quartz.
You are wrong.
What?
You're wrong.
This is rigged.
The answer is porcelain.
Oh, that was my other because okay.
It melts at 1,927 degrees Celsius.
I mean, let me get the forge going. We'll find out if that's true.
It's hot. All right.
And that was Celsius, right?
That was Celsius.
Fahrenheit, it's even higher.
Yes.
Wow.
I don't know how. Is that true?
Give me a second.
Because 0 Celsius is 32 Fahrenheit. I think that's true.
Right. Yeah,
Fahrenheit's bigger.
Give me a second. I'll pull up my because
your converter.
I'm a nerd. Yeah. Wait. Am I going to hurt the game if I do?
No.
Okay. I have, so everyone knows right now I'm working on actually building a foundry and melting metal. So I have in Celsius as well. So let's take aluminum for example, right? 659 degrees Celsius, aluminum would melt. That is 1,218 degrees Fahrenheit.
Right. So Fahrenheit numbers are bigger.
So if you said 1,900
and 27 degrees Celsius,
that's
it's hot.
It's hot.
Yeah.
And just in like relative terms, the foundry we're making, it'll go up above 3,000 degrees
Celsius.
It's going to be Fahrenheit.
Fahrenheit.
Yeah.
Okay.
Yeah.
All right. Next question.
Yes, go for it.
What is the coldest natural temperature where people live? So in the winter, it gets this cold. It's the coldest place people live on Earth. Is it negative 60 degrees? This is Fahrenheit.
Ooh.
Negative 60, negative 40, negative 20, or negative 10?
I don't know. I think negative 10 is. But I'm going to say negative 60.
You're wrong again.
Guys, I'm not good at this one.
It's negative 40.
Oh,
it is Yakutsk, Siberia. And it routinely gets to be roughly negative 40 degrees in the winter.
Isn't it like the sun is never out there or something like that?
Yeah, so above the Arctic Circle. I don't know if Yakutsk is... Guys, is it Y-A-K-U-T-S-K? Yakutsk. I don't know if it's above the Arctic Circle, but above the Arctic Circle, there are days where the sun never rises, and there are days in the summer when the sun never sets. We talked about that last week on our Earth Day episode, so you can check that out. You almost guessed negative 10. It gets negative 10 in Ohio.
Excuse me, I'm sorry.
Come on, bro.
All
right.
You said living, and I was like, well.
Next question. What is the hottest planet in our solar system?
What's up? How you doing?
Is it Mars, Venus, Jupiter, or Earth?
Okay. I mean, I want to say Earth because how
it's
you
hot.
doing? It's fly. Like it's a different hot.
Yeah.
It's like HAWT, like
hot.
It's cool. But I'm gonna say Venus.
You're correct.
Venus is very, very cool. It's like super acidic. They have acid rain there.
Yeah.
Very
so
hot.
What's
temperatures.
interesting about Venus, it's not the closest one to the sun.
No.
So you would expect the closest one to the sun to be the hottest. But Venus actually has an atmosphere entirely made out of greenhouse gases. So we're all worried about greenhouse gases on
it's
Earth.
like we shouldn't mess with that up there because you could get a Venus.
Yeah,
you know?
So basically it acts like a greenhouse, like an oven. Like all the light comes in and none of that energy can escape back out.
Mm-hmm.
And it is actually on the surface, it's the hottest planet in our solar system.
I think there's like a Doctor Who episode where they go to Venus and like they can't navigate because it's so bad.
That's cool. I thought I've seen every episode of Doctor Who, including almost all the old ones.
It's Mercury, right?
I don't
That's like
remember.
the closest to the sun.
It's one of the M ones.
I think it's Mercury.
I know the mnemonic.
Yeah, and that one's
I think it's
like
Mercury.
super desolate. Yeah.
Okay. Here's the last question.
Okay, go for it.
There is a natural gas vent in Iraq that is currently on fire. It is called the Eternal Fire. Some people call it that.
Wait, a vent that's just always on fire.
Yep. How long has it been on fire? 100 years, 400 years, 1,000 years, or 4,000 years?
Well, I want to say C because that's always like the right answer, but I'm actually going to go D.
You're correct.
4,000 years?
4,000 years, roughly.
What?
And
this
some
is just
people...
like a spout of fire.
It's not really a spout. It's like a field.
A field?
Fire. And some people think it's actually mentioned in the Bible. Some people think it's mentioned in the book of Daniel where they have Shadrach, Meshach, and Abednego in the fire. And the fourth person appears. I know. And so, so that's the eternal fire. I don't know if that's really the fire in the book of Daniel, but that's what
what
the interwebs told me. So if you guys have enjoyed this volcano episode, I know we have, please consider checking out our Patreon program. Go to I'llTakeMyScienceNeat.com. You can check out our patron video where we talk about freeing science and science literacy. You can check out our shop on there if you're interested in some super cool science nerdy t-shirts and bags and mugs. And just most importantly, thank you for listening. We aren't in this for the money. We're in this to share this cool science with you. So if you can just share it with your friends, and just always remember, if anyone asks you how you want your science, tell them you'll take it neat.
Have a great Friday, a great weekend, a great day, wherever you are. See you next time.
See you next time.